basically what I'll do, we want part 1 number 4, part 1 number 5, 10 and 11, part 2, 4, 5, 6, 7, 4, 5, 6, 7, 4, 5, 6, 7, 9, 10, 11. 9, 10. All right. Go through the circled ones, and then question number 4, I'm going to highlight the word defined because this is key to understanding what this question is asking. It is asking when something is asking where it's defined, it is asking where, in other words, the domain, is it possible? And a lot of things in math, it's always possible, right? Like, is there any number you can't add 3 to? You're like, 5 plus 3 is 8. But no, you're never allowed to add 3 to this number. No, you're always allowed to add 3 to them. But there are some things in math you're not allowed to do. And so far at this point, I think you've only learned 2 of them. The 2 things you're not allowed to do you know that you're not allowed to divide by 0? You're also, so I can put it in, that would be bad. You're also never allowed to square root a negative number. That also would be bad. So when a question is asking where is something defined or where is it possible, part of your brain goes, well, what are the things that are not possible? It's not possible to square root negatives. It's not possible to divide by 0. And in this question, we have a square root sign. And we also have a dividing. So we have some things to consider. Now, as far as the square root sign, oh, thank you. Otherwise, that recording would have been really bad. Thanks for noticing. Okay. So things that are not possible are dividing by 0 and square rooting a negative. In this question, let's start with thinking about the negatives. According to your cast rule, because we're looking once around the circle from 0 to 2 pi, can you see that for cosine, quadrant 2 and quadrant 3 would be bad? Because that's where cos is negative. So it is only good in quadrant 1. And quadrant 1 starts at 0 and goes to pi over 2. And quadrant 4 starts at 3 pi over 2 and goes to 2 pi. So I'm going to write these in interval notation. So I have to put brackets around here. And I'll put a square bracket when a value is included and a round bracket when a value is not included. So this is where cos is positive. But we also have the possibility of dividing by 0. When is cos x equals 0? If I just write it off to the side here. Cos x is equal to 0. Well, cos is your which coordinate? Your x coordinate. And your x coordinate is 0 at pi over 2 and 3 pi over 2. So 0, when I plug in 0 for x, cos of 0 is actually equal to 1. Are you allowed to divide by 1? Absolutely. So this will be a square bracket. But when I plug in pi over 2, cos of pi over 2 is 0. That'll be a round bracket because that value is not included. Same thing, 3 pi over 2 will give you 0, not included. 2 pi will give you a square bracket. And in interval notation, when we have 2 intervals, we put a u in between them. So when you look in the back at the answer key, that is how that interval is determined. The cast rule where it's positive, and then the brackets on the endpoints is whether or not you can divide by 0 or divide by what number is there if it works. All right, question number 5. P theta is a point on the unit circle, then P12 appears in which quadrant? If the 12 had a little degree sign, this would be super easy and you could say quadrant 1. But the 12 doesn't have a degree sign, and so that means it's in radians. Part 1, calculator or non-calculator? So since it's calculator, you could do this on your calculator. Make sure that if you're using a calculator, you either use your fraction button on your calculator and write it like this, 1.909. How does this tell me it's in quadrant 4? How do I get that number and right away know it's in quadrant 4? The 1 is 1 full revolution. And then I have a 0.9 of a full revolution. Does it make sense that if you take your 4 quadrants, and this would be halfway around, this is a quarter of the way around, this is 3/4 of the way around, 0.9 is more than 3/4, it would have to end in quadrant 4. If this same question shows up on a non-calculator part of your test or quiz, you know that all the way around is 2 pi, and you know that pi is 3.14 approximately. So 2 pi is approximately 6.28. Halfway around would be 3.14. Half of 3.14, pi over 2 is approximately 1.57. Okay. I need to find out where 12 is. Can you see that 12 is more than 6? If I went around 4 pi, if I doubled this would also be coterminal with 12.56. Well, 12.56 is too much. I'm looking for 12. If pi over 2 is 1.57, if I take off 1.57, it's going to be really close to 11. It's past 11, less than 12.56. I could figure out it's 12 has to be in quadrant 4 for that reason. But the key thing to notice in this one, when no units are written, it always means radians. Six, 7, 8, 9, 10. Next question is 10. Explain why the expression equivalent to cos theta minus pi is equivalent to negative cos theta. So this is one which is easiest if you use graphs. And so I am going to graph y equals cos theta minus pi on one graph. I'll do it in green, and I'll graph negative cos of theta on another graph. So if I think about DAB C, on this has green, on this has brown. Can you see that this would be a normal cos graph, just shifted pi units to the right? Okay, so I'm going to DAB C, my amplitude is 1, my center line is 0, my period is 2 pi, so I'm going to mark 2 pi, split it into 4 equal sections. And I'm going to start in purple, just drawing in a dotted line. This is my normal cos graph, no shift. You see that my green graph has a shift of pi units to the right. So this would go to here. This point to here, this point to here. Next ticky mark would be back at the center line. Next ticky mark would be back at the maximum. You can work backwards. There is my green graph shifted pi to the right. Right beside it here. normal coast graph. My normal coast graph with the dotted line in purple. Let's go. Is my normal coast graph. What does the negative do? Flips it. So now in blue, this point would get flipped to here, then this one up to there. Can you see that the graphs are the same? The graphs are the same. They have the same period, they have the same starting point, the same amplitude, the same center line. So our explanation is the graphs are the same. And number 11. Secant is 1 over cos. And this question, take out my highlighter again uses undefined. The other question that we had the word defined. This one says undefined. Undefined is looking for a non-permissible value. We are looking for a non-permissible value. What can't we do? We can't divide by 0. When would we divide by 0? Well, on your pie plate, cos is the x-coordinate. When is the x-coordinate equal to 0? At pi over 2. Or 3 pi over 2. Those would be all the answers between 0 and 2 pi that would cause you to divide by 0. And those would be the places where secant is undefined. Okay, question part 2, question number 4. Is 112 degrees on your pie plate? No. And this is without a calculator. So how am I supposed to figure out cos of 112 degrees without my calculator? And especially when if I show you on my calculator, cos, I have to be in radians. There we go. Go to mode. In radians, go to degrees. If I type in cos of 112, you're like, how am I expected to know that without my calculator? Well, you don't. You don't have to know that, but you can still do this question because it's your big idea. Our big idea says that sine squared theta plus cos squared theta, if these thetas are the same, what is it equal to? 1. So the answer to question number 4 is just 1. Without having to need a calculator, you just use the big idea. If the angles were different, you would not be allowed to say that. Only the big idea, this theta is this theta, they have to be the same. If the angles are different, as in, a question was right before this, there was one. Yeah, 2. You can't do that in number 2. Number 2, you'd have to use your pie plate values. And if it's not on your pie plate and they ask you to do it, it'll be on a calculator section. So they will only ask you ones that are available to do with. I can do question 2 as well, just to see it. So on my pie plate, sine of 45 is root 2 over 2. So sine squared of 45 will be root 2 over 2 squared. And cos of 60, well, 60 on my pie plate for cos is 1/2. So cos squared will be 1/2 squared. If I square this, I'll get 2 over 4. I square this, I will get 1 over 4. Added together, they become 3 over 4. So on that one, I have to go to my pie plate to get to that. Question number 5. Question 5 is tricky for this explain thing. There's a lot of ways that you can get the right answer with the wrong explanation. No, you have to have, so I'll give you a blank paper you can write your plate on, but you have to have your unit circles memorized for tomorrow.
Next unit, we don't need it.
That's right. Next unit test, and you'll get to use it on your next unit test. Okay. So what makes this one hard is if you pretend to use the big idea with a plus sign, you'll actually get the right answer. Totally coincidence. So we have to understand what's happening here. Okay? I'll give you sort of two different ways to think about it. I'll split my page here. You can decide which one makes the most sense for you. Explanation number one. First of all, some observations. Cos squared x, sine squared x. Whenever you square something, would you agree that it's going to be a positive number or 0? The smallest it can be is 0. The biggest it can be is whatever, depends what you're, but when you square a number, it's no longer negative. Okay? So the next observation I notice here is I want this to be big and this to be small. Because I'm going to do this number minus this number. Now, let's start with the small one. If the smallest something can ever be is the 0, right? Can sine ever be 0? Sine squared x equals 0 when x equals, right? Sine is your y coordinate. When is sine equal to 0? At 0, at pi, and at 2 pi, right? It just so happens, okay, so technically I can make a note here. This is the smallest possible. What's the biggest cos ever gets? Think of your cos graph. What's its maximum? 1. So the biggest I would ever get if I square it would be when cos is 1. It just so happens when x equals 0, cos x equals 1, which is the biggest it could ever be. Therefore, if I want to find the maximum here, the biggest cos can ever be is 1. I can even say at x equals 0, I get that perfect situation. The smallest sine can ever be, the biggest cos can ever be. Okay? Method number 2. Method number 1 is hard because you have to think about cos and sine. You have to think cos has to be big, sine has to be small. In method number 2, I use my big idea and I say I know that cos squared x plus sine squared x equals 1. So I can move the sine squared x over to the other side and say I know that cos squared x is equal to 1 minus sine squared x. And I replace that in my question. And I like this a little bit better just because it takes a little bit less understanding. Now I only need, because you're subtracting it, and I only have one thing that I need really small. Because sine squared is always positive, So I need that to be as small as possible, because otherwise you're subtracting something. The more you subtract, the smaller your number's gonna get. So then my work just becomes 6 times 1 minus 0 minus 3, and I get a maximum value of 3 that way as well. I find that that one is probably a little bit easier to explain, because the first one, both things have to be working for you at the same time. And just by coincidence, the smallest sine ever gets is 0, and the biggest cos ever gets is positive 1. It works out. The second one, with a little bit of a substitution, now you only have to explain one thing, that you want sine squared x to be as small as possible, and since it's squared, the smallest it can be is 0. Which leads nicely into question 6, because question 6 says you should use the big idea of sine squared plus cos squared equals 1 as well. But in this one, this time I'm going to get the sine squared by itself. So technically, this question right now is hard to solve because it has a sine x and a cos x in the same question. It's like having two variables almost in the same question. But if we use the big idea, we can use substitution to replace, right? This is my question, this is the original question, but instead of writing the sine squared in the blue brackets there, I can replace it with the big idea that sine squared x is equal to 1 minus cos squared x. And now I have only cos. Having only cos means, well, maybe I can either use quadratic formula or factoring. Either way, quadratic formula or factoring, I need to make one side equal to 0. Personally, I like to make the cos squared thing positive. So I'm going to move everything over to the right. So the negative cos squared over to the right becomes positive cos squared. The negative 3 cos x moved to the right would become plus 3 cos x. And if I move the 1 over, I have plus 2. Either quadratic formula or factoring. I'm going to try to factor here. Cos x and cos x would be the only way I could get cos squared. Only way I could get 2 and 1. Does my outside and inside make 3? It does, if they're both positive. So you would split it here. I'll just continue it over here. If I split it there, that means either cos x equals negative 2 or cos x equals negative 1. Now this is non-calculator question. So that means these values have to be on your pie plate, or you have to be able to figure them out some way else. I recognize minus 1. Definitely on my pie plate. When is your x coordinate minus 1? Here's my x coordinate minus 1 right over here, right? At pi. When is my x coordinate 2? Oh, 2 pi is 1.
Oh, right.
How do I do this without a calculator? It's not on your pie plate. It's not possible. Because this would mean 2 over 1. Draw a triangle where your adjacent side is 2, your hypotenuse is 1. Impossible. So anytime you get a number bigger than 1 or technically less than negative 1, either a positive or negative number bigger than 1, it's going to be not possible for sine and for cosine. Tangent, it's allowed. But sine and cosine, it is not. Here we have this part. Tells us we're looking for a general solution. So just a little note. In class, we first solve between 0 and 2 pi. That was the notes that we had in class. First solve between 0 and 2 pi, and then solve afterwards. Do you notice this is a quadratic? Okay? I'm going to say it, I'm not going to show you this, some of you are going to do this on quizzes often. In solving questions, sometimes you are going to be tempted to make the equation simpler by dividing. I can make this question just look like tan x equals root 3 over 3 if I divide by tan x. However, if you divide by a variable, you might accidentally, without knowing it, be dividing by 0. For example, can you see here that if tan x is equal to 0, this left side would be 0, the right side would be 0? It's actually a solution that tan x could be 0. And if you divided both sides by tan x, you'd be dividing by 0, which actually would be bad, but you wouldn't even notice. So whenever you're tempted to divide, factor instead. So if I want to solve a quadratic, I need to make one side equal to 0. So my very first step here is I will subtract the root 3 over 3 tan x from both sides, make it equal to 0, and then instead of dividing, I would say there is a common factor of tan. So I can factor that out. And now that it's factored, either this is equal to 0, in which case tan x is 0, or this is equal to 0. And you still get that other solution, that root 3 over 3 solution, but now you have both of them. And these are all on our pi plane. When is tan equal to 0? 0, pi, and 2 pi. So in the purple there, right? I want to find all my answers between 0 and 2 pi. Is the 0 minus?
No, sorry, the root 3 over 3 minus, because you're minusing the from. So
Because there was a subtraction here,
yeah.
then there's a subtraction here. Then we're asking what would make this 0 is if it was the opposite, positive root 3 over 3. And root 3 over 3 is your pi over 6 family. According to our CAS rule, we would look in quadrants 1 and quadrants 3 because tan x is positive. After you find your answers between 0 and 2 pi, you now can write your general solution. Okay? I will write it, both of these ways are right. I will write it a short way and I will write it a long way. You will not lose marks for writing it the long way. The long way just says take all 5 answers. Okay? Pi over 6 and 7 pi over 6. There's all 5 answers. Add 2k pi to each of them. But some of you might notice that, hey, wait a second, some of this is a little redundant. For example, if I write everything coterminal with 0, does that not include 2 pi? And if I write everything coterminal with 2 pi, this for sure, here and here, is a repeat. It's not necessary to write it twice, but you don't lose marks, right? If you're really mad at me one day and you have a question like this, you could do billions of answers plus 2k pi and just spend hours writing the super longest answer in the world, and I would have to still mark it as right, even though you've said the same answer over and over again. Right? Question.
Can you just explain quick how you got your answers for tan again?
This is just from a unit circle.
Yeah.
Having this memorized. So I know tan is 0 here, and here, and here. Root 3 here, and here. Okay? If I wanted to make this answer shorter, I can actually combine the first 3 as just k times pi. That'll include 0, 1 pi, 2 pi, 3 pi, 4 pi, all the negative ones. So I can combine those first 3 I'll underline in orange. I could combine them here. And these in purple, I actually could combine. It just so happens that pi over 6 and 7 pi over 6 are exactly halfway around the circle from each other. So if I started at pi over 6 and added pi, I'd get to 7 pi over 6, and then added pi again, I'd get back, and I would get both of them, all of their coterminal ones, all the way. So this is the same answer, shorter form. Okay. The only time shorter forms become important is if you get a multiple choice question on the exam, and you got the long answer, but the multiple choice listed as shorter version. Okay? And the ones that can make it the shortest are only with tan. You can only combine opposite things in tan because they're halfway around. If you had sine and they were both positive, one would be quadrant 1, one would be quadrant 2, and it's not an equal jump in between. Question number 9. Question number 9 is very easy to get half right, but a little trickier to get it fully right. If you use the CAST rule, lots of students get it half right using the CAST rule and say that it has to be quadrant 4 because sine is negative and cos is positive. But the best way to solve number 9 is with graphs. So I'm going to, in green, draw sine, and in blue, I'm going to draw cos. So here, one period would be 2 pi, divide into 4 equal sections. Amplitude is 1 and negative 1. My sine graph starts in the middle, going up. And my cos graph starts at a maximum. And I'm looking for where sine is less than cos. On my graph, can you see that there's only 2 places that they're the same? Those 2 places are the same. I'm going to take out a highlighter. I'm going to highlight the places. That section, you see your green graph is below your blue graph. Your green would be less than your blue. And in this section here, your green graph is less than your blue graph. So my solution is going to start at 0 and go up to this red dot, but not include it. Where is that red dot? Think about your pi plane. That red dot is where sine theta and cos theta are the same. Do we have a place on our unit circle where they're both the same value? Right? That's your 45 degree or pi over 4 family. So they're going to be exactly the same at pi over 4. Then at the next red dot, up to 2 pi, they're going to be the same. When is the next time that they're exactly the same on your pi plane? It has to be in quadrant 3, because they're both negative in quadrant 3. And what's your pi over 4 family in quadrant 3? That next dot is at 5 pi over 4. So I could ask this question, I could switch the sign around. I could say sine theta bigger than cos theta. I could switch the order around. I could have cos first, less than sine. But the best way would be to draw a graph see where they are the same, and then where's my one graph less than the other graph. Question number 10 is a multi-revolution question. Tan of 3 theta is equal to -1. How do we solve multi-revolution questions? The first thing we do is we rewrite our domain for 3 theta. If 1 theta is once around from 0 to 2 pi, 3 theta is going to be 3 times around from 0 to 6 pi. Then we solve for 3 theta, right? 3 theta is the angle. You could add in that green box an x, and you could solve for x. Right? You'd ask yourself, is tangent ever -1? Well, is tangent ever 1? That's my pi over 4 family. But negative, so I'd be looking in quadrant 2 and quadrant 4. What are my pi over 4 family in quadrant 2? Oops. Quadrant 2 would be 3 pi over 4. Quadrant 4 would be 7 pi over 4. But that's only the first time around. So if I have 3 pi over 4 and 7 pi over 4, the second time around, I would get something coterminal with 3 pi over 4. How do I figure out that it's 11 pi over 4? Well, if it's coterminal, to get from this one to this one, I would add 2 pi. But in order to add 2 pi to pi over 4, I have to think I need a common denominator. Would you agree that 2 pi is 8 pi over 4? And then if I take 3 pi over 4 plus 8 pi over 4, I get 11 pi over 4. And once you figure that 8 pi over 4 out, you're also going to easily figure out that this one is 15 pi over 4. Because that's coterminal with 7 pi over 4. We've now gone how many times around the circle? Twice. How many times do we have to go for this multi-revolution? 3 times. So I add 8 to this one, 19 pi over 4. I add 8 to this one, 23 pi over 4. Once you've solved for 3 theta, if I want to solve for theta, I would have to divide by 3. Dividing by 3 is same as multiplying by a third. I take each of those fractions and I multiply them by a third. And I know I could have simplified that one, but that's okay. You see that that 1/3 multiplying would just change the bottom of each of these to 12? And we get 6 answers. Question number 11. I'm going to show you 2 ways that you can do it, because in the answer key at the back, there's 2 different answers, and if you're like, where did the answer 2 come from? How did they get that? I'll show you 2 different ways. First of all, I'll show you the normal way that we've done all the way along. Okay? This is, first of all, I see it is a multi-revolution and a general solution in the same question. Okay? So I'm going to use the strategy of thinking about general solution first and thinking about multi-revolution second. And then I'm going to solve where I think about multi-revolution first and general solution second. So, how do you find a general solution? You first solve between 0 and 2 pi. And then we're going to add 2k pi to everything. But if I'm solving between 0 and 2 pi and it's multi-revolution, then I have to write my domain for 2 theta which would be between 0 and 4 pi. And if that was just an x inside that box, you could solve for this. So we solve for 2 theta. Root 3 over 2, is it on your pi plate? Yes. What family? For sine? Pi over 3. It's positive, so we would have quadrant 1 and quadrant 2. But since this is a multi-revolution, how many times do we have to go around the circle for this one? 2 times around. So the second time around, what number am I going to add to the top? It's going to be add 2 pi, right? If you think, but now my 2 pi is 6 pi over 3. So add 6 to 1, I get 7. Add 6 to 2, and I get 8 pi over 3. Then I can solve for theta by dividing everything by 2, which is multiplying by a half. And I could reduce some of these, but I'll just leave them all over 6. Don't lose any marks for not reducing fractions in grade 12. The only time it's really important is in a multiple choice where you'd have to recognize that 2 pi over 6 is the same as pi over 3. So we have solved for our answers between 0 and 2 pi. Now, we can take each of the answers and add 2k pi to all of them. And this is the general solution. So this is one method that you could do. Second method is a little bit more elegant. Okay? So instead of doing the general solution first and then multi-revolution, we start by writing the general solution, oops, not 3, it's 2 theta, for 2 theta. How do you write a general solution? You solve for 2 theta between 0 and 2 pi and add 2k pi. So do you see we've already solved for, like, if I have sine of 2 theta equals root 3 over 2, solving for 2 theta between 0 and 2 pi is just pi over 3 and 2 pi over 3. Same thing we had over here. So our general solution for 2 theta would be pi over 3 plus 2k pi and 2 pi over 3 plus 2k pi, where k is an integer. That's the general solution for 2 theta. If you know the general solution for 2 theta, what do you think you'd have to do to find your general solution for theta? Divide everything by 2. If I divide everything by 2, my pi over 3 becomes pi over 6. Oh, there we go. My pi over 3 becomes pi over 6. And my 2k pi becomes, it has to get divided by 2 as well. Just becomes k pi. And 2 pi over 3 divided by 2 is just pi over 3. And 2k pi divided by 2 just becomes k pi. K is still an integer. And it's a little bit more elegant because there's less things written in the end. But that's a new method we haven't seen in class yet. This is the first time that we're sort of seeing that as a method. So you can choose which one you like better. Either you solve first between 0 and 2 pi and find all of them with a multi-revolution, add 2k pi to all of them, or you write the general solution first for the angle and then solve after that. Alright, now that we've done those ones, was there any ones that we skipped, now that you looked them over, that you would like to also do?